So, welcome to this oral session talk belonging to poster 738 on Monday and Tuesday, in which we address structural and functional MRI and their predictive value for chronological age and memory performance. So our research starts from the observation that although cognitive performance generally declines with increasing age, as is here shown for memory performance, some older adults show memory performance comparable to that of young subjects, and these individuals are typically called successful agers. It is yet to be revealed why successful agers are so successful. One possible explanation is that there is higher brain structural integrity in these individuals as compared to other subjects who are more strongly suffering from brain-related atrophy. So this could be called brain maintenance. Alternatively, the brain might simply recruit existing resources more efficiently or even employ compensatory cognitive strategies. This could be termed cognitive reserve. And our assumption is that although we cannot strictly decide between these theories, we can at least provide some evidence by testing the predictions that these theories make. Because according to the brain maintenance view, differences in memory performance within the older subjects should co-occur with differences in structure MRI. Whereas according to the cognitive reserve theory, differences in memory performance should correlate with differences in functional MRI responses. So we measured functional MRI brain activity of young and older subjects while they were seeing either novel images, which they had not previously seen, or 1 out of 2 master images, which were pre-familiarized and thus known to the subjects. In a subsequent memory test, the subjects were then shown all the old items which they had seen in the encoding session, as well as several new images, and they were asked to provide to rate these images on a 5-point scale ranging from 1 for this item is definitely new to me, up to 5 for I've definitely seen this item before. So this allows to categorize encoding events based on the retrieval responses, and then we can infer on fMRI activity differences with respect to novelty processing by contrasting novel with familiar images, and to infer on subsequent memory effects by contrasting remembered with forgotten items, which is here shown on the left and right, respectively. In previous work, we have shown how from these fMRI contrasts, we can derive summary statistics indicating either deviation or similarity of a given older subject from prototypical activations seen in young subjects. One of these scores is the so-called fate score, which subtracts for a given contrast the average activity within a predefined brain mask from the average activity outside this mask. We have developed an improved statistic called the same score, which directly operates on activity differences, which also takes into account the deactivations on the respective contrast, and which factors in the variability of the young subjects used as a reference sample. So we have fMRI contrasts indicating neural correlates of memory formation. From these contrasts, we can derive single value fMRI scores. We have the behavioral data for all subjects, that is, how often they responded 1 to 5 with respect to old versus new items. And from each subject, we also acquired structural MRI scan, from which we extracted voxel-wise gray matter volume, and a resting state fMRI session, from which we extracted voxel-wise mean percent of amplitude fluctuation, or M/RF in short. So we used these feature sets to predict several variables of interest, namely age group, that is whether a subject was young or old, chronological age in years, and memory performance measured as area under the curve in the subsequent memory test. We used support vector classification with tenfold cross-validation for the discrete variable age group and support vector regression for the continuous variables age and memory. First, we assured that age group can be classified from all these variables. And here we are already seeing a clear hierarchy from behavioral over functional up to structural information. If we then look at the continuous variables, chronological age and memory performance, we find that within the older subjects, here shown on the right, chronological age is best predicted from structure MRI and resting state fMRI, which are shown in green and cyan. However, these two have no predictive value with respect to memory performance in the older subjects, which in turn is best predicted by functional MRI contrasts and especially fMRI summary statistics or single value fMRI scores, which are here shown in blue and magenta. So in order to follow up on this finding, we performed a subgroup analysis within the older subjects and partitioned them based on either chronological age or based on memory performance. And from these partitions, we took the lowermost and the uppermost quartile and performed a true group comparison within the older subjects. So this revealed a double dissociation between memory versus age on the one hand and functional versus structure MRI on the other hand, in a sense that when partitioning older subjects by chronological age, there are no significant effects with respect to functional MRI, but strong differences in gray matter volume, whereas when partitioning older subjects by memory performance, there are no significant effects with respect to structure MRI, but robust differences in the memory-related brain activity. So to sum up, we found that chronological age is best predicted from structure MRI, but functional MRI is the best predictor for memory performance. Moreover, single value fMRI scores derived from the fMRI contrasts were just as good or even better than taking the whole brain fMRI contrast for predicting memory performance. So taken together, our results suggest that superior memory performance in healthy older adults is better explained by efficient recruitment of the brain's memory network rather than preserved brain structure. So with that, I want to say thank you. I'm looking forward to your questions in Glasgow. And if you want to know more, please come to my poster 738 on Monday and Tuesday. And if you want to know even more, please also check out these other posters from my lab. And thank you again.